week is crazy. Because Thursday there's a program in the morning and in the afternoon. So what's going to happen, we cannot get any further behind in line. What's going to happen is, we have one tiny thing, well it's not tiny, but one important thing to talk about today, and then we've got all we need to quiz. And there's really not much left to test. So I'm telling you there's a quiz tomorrow on 4.1, but the whole entire test for this unit is next Tuesday. We really don't have that much left. So our plan is quiz tomorrow, notes Wednesday, and I'm going to post, either I'm going to see your face and life will go as I want it to, which probably won't happen. I'm going to post a video of notes on Thursday. Nick can watch it Thursday, he can watch it Friday, he can watch it Saturday, Sunday. I don't care when Nick watches it, but Nick ought to watch it because Monday's going to be review and Tuesday's going to be test. And the material discussed on the video on Thursday will potentially make the test. Okay, so we got all that out there. You weren't here on Friday. We didn't have all of us, so we seriously, everyone's tired of me graphing quadratic, so we decided we can handle it on our own. So we just worked on our homework from page 7 from last week and our checkpoint 4.1. I'm not typing in the zeros for that until tomorrow, but I am going to type in the zeros for that tomorrow. So if you weren't here or you were here and just still don't have it done, you need to get that handled by tomorrow. Okay, can someone help me with number 1? 3 and 5, get a point. That's perfect. What about number 2? And I know you used grouping for that, so let's see. You said you took out a 2x, so you were left with a 4a minus 3. You took out a negative 3, so you were left with a 4a minus 3. So that's how you got 2x minus 3, 4a minus 3. That's perfect. Again, 3 and 5. Number 3 is one of my favorites because it's got a leading coefficient of 1, so who gets the point? So since it has a leading coefficient of 1, I need two things to add to 6 and multiply to 8. Ellie's group again. 4 plus 2 is 6. 4 times 2 is 8. Well, you had like 10 minutes. She was productive. Good for her. Okay, and then number 4 is for real my favorite of the day because it's at 4 gets the point. I love perfect squares. Did you really? You can have the point page. I love it because it's perfect squares. I know 2 squared is 4, so it's a 2b and a 2b. But what's 625? Yes, Daniel. So positive 25 and negative 25. So I wrote it tiny, but it's 6b plus 25. 2b plus 25. 2b minus 25. Number 5 is the only bummer of the day, and that's because that leading coefficient is, bless its heart. So if the middle term was a 56, this would actually go a lot nicer for us. Why is that? 7 goes in 56 and 28, and we would be able to pull out a GCF then. Yes. Okay, but it doesn't, so we can't. So instead, I've got to come up with factors. There is no GCF. I'm thinking of things that multiply to 28. I know 1 and 28, 2 and 14, 4 and 7. Now, later this week, so this is the part that we have left after today. Later this week, I'm going to discuss different ways you could potentially factor when the leading coefficient is not a 1. But honestly, if you're understanding what I call guess and check, to me, that is the best, most mathematical way because it shows you understand your math skills. So, I know the first term is a 7a, and the next first term is an a. And the reason I know this is because only 7 times 1 is 7a squared. Now, if it was a 9, we could debate, is it 9a and 1, or is it 3a and 3a? But because it's a 7, my only options are 7 and a, 7a and a, because that gives me 7a squared when I FOIL it back out. And then from here, I get to guess. Okay, so we could guess 4 and 7. Or we could guess 7 and 4. Let's guess 7 and 4. I'm literally just guessing. I know these are my options. I'm just guessing. I know they both have to be positive because both my inside term, the 53, and my last term, the 28, they're both positive. Okay, I FOIL it out to check. So I've done my guess and I'm doing my check. First is 7a squared. Outer is 28a. Inner is 7a. Last is 28. And I'm sad because 28 plus 7 is 35, and I needed a 53. So my guess was wrong. But that's the whole point of guess and check. Aren't I going to give you points for trying, even if you're wrong? You tried. Okay, so Daniel said, I guess he tried it out. He said, let's do 7a plus 7. He wants to swap the 7 and the 4. He said, why don't you put the 7s together? Oh, I did that wrong. 7a plus 4. He wanted to do it opposite, and I didn't do it opposite. He wants to put the 4 in the left spot and the 7 in the right spot. So the opposite of what I just did. Okay, so he did 7a plus 4, a plus 7. He FOILs it out, so 7a squared for the first, outer is 49a, inner is 4a, and last is 28 again. What's 49 plus 4? So we actually did get 7a squared plus 53a plus 28. So we actually got our answer. So that guess is correct. The answer is, for real, 7a plus 4, a plus 7. Goodness gracious. Speaking of all the things, there's another thing that we cannot postpone any longer. It is happening on Wednesday because it cannot wait any longer. I'm going to put it on the screen now. Yes, you can have a point for that. I'm going to put it on the screen now. If you need to cheat and look off the screen, you can. Hopefully you've got a couple of these down so you won't. Where did you go? Perfect Cubes is on Wednesday. It's on the back of your last packet. You're going to have a minute and 20, mostly because you got to have a couple seconds to write your name. Okay. So let's do this. 1 cubed, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed, 7 cubed, 8 cubed. If you don't know, you know it's on the screen. 9 cubed, 10 cubed. Okay, but that was terrible of me to do it that way. Why? 2 gets another point. I did it in order. The test is not in order. So let's do it random now. Let's see. 3 cubed. 6 cubed. 1 cubed. 10 cubed. 4 cubed. 2 cubed. 7 cubed. 8 cubed. 5 cubed. 9 cubed. Okay. So if you know yourself, did you know that or not? We'll do the same game again tomorrow, but that's still Wednesday. Minute 20 seconds. Going in the 60% category, 10 points.
Oh my gosh.
Okay. Moving on. In case you haven't noticed, we have a quiz tomorrow. So let's look at what we've been doing lately. We have been graphing quadratic functions, and we've been making a list of 6 things. Can anyone tell me the list of 6 things before I flip to it? All right, 3 and 4. Yes. Okay, so today we're literally going to add one more thing to this list. So yes, it is important when you're given a quadratic function, can you determine the y-intercept, the axis of symmetry, the domain, the range, the vertex, the min, the max. We've talked about how the domain you automatically should know. You should automatically know if it's a min or max. Maybe not where, but which one it is. It's one or the other. And you should automatically know one last thing. What is that? Yes, you should automatically know the y-intercept. 3 again. Otherwise, you can calculate it by hand using formulas like the axis of symmetry is negative b over 2a. Or you can use your handy-dandy calculator. Your handy-dandy calculator is the best. And so I graph whatever I need to graph, and I can press second table and look at specific points on my graph. But sometimes second table disappoints me. Why does second table let me down?
Sometimes they're fractions.
What if they're fractions or decimals and you were saying whole numbers, so 2 and 3? So if it's a fraction vertex, second table's not going to help you figure it out. What have we been pressing if it's a fraction or a decimal? Second calculate, and that's the button we're going to press again today. That is the button we're going to use to press again today. So again, second calc, and then we set the bounds. We make a guess, and it tells us the answer. It's magical like that. Okay, so we are, I need to change it. It's not notes page 9 through 11. We're on page 4. So it's literally this. Now we're trying to hurry, so we're going to skip the top little thing. We're going to go straight to that first little box and talk about all the vocab words we need from there. Okay, so quadratic functions are great, and all the stuff we talked about is great, but genuinely, probably what most would consider the most important part of a quadratic function is the thing we haven't discussed, which is what we're discussing today. We've discussed y-intercepts, but we've yet to discuss calculating x-intercepts. So today we're talking about x-intercepts. With a quadratic, x-intercepts are so important, they actually have their own vocab terms. So some people might call them roots, and some people call them zeros. We'll discuss the difference between a root and a zero another day, one thing at a time. There is a difference, but that's another day's problem. So again, just where it crosses the x-axis, that x-intercept, you might call it a root, you might call it a zero. So for instance, they've given us a picture of 3 different ones. This one has 1 root, or 1 zero, or 1 x-intercept. This one has 2 roots, or 2 zeros, or 2 x-intercepts. And then the last one doesn't cross the x-axis at all. So it doesn't have any. So first period I put a 0. But that's kind of misleading because then people think the intercept is at 0. So maybe we should just put no roots, or no x-intercepts, or no zeros. Maybe we should put the word none of those, or no solution, whatever it is you need to put. But if you put 0, you see how it's misleading, because then I'm thinking it is an x-intercept at the origin. Okay, so we spent all this time in our math workshops on factoring. Factor this, factor that, factor. And you're like, why do I factor? Well, what we're going to find out on Wednesday is that we've been factoring this whole time, and that the things we've been factoring are actually giving us the answers. So our factors are actually telling us where our graph is crossing the x-intercepts, like where those happen. So that's Wednesday's problem, to like apply factoring to this. Today we're going to keep it simple. Literally, we're going to graph these in our calculator, see where the x-intercept is, and write those down. That's not easy of a day. In fact, the first 3 they've already given us a picture. We don't even have to graph those. They graph them for us. So number 1, what should I put for the x-intercepts? Yes, table 2. It has no roots, or no intercepts, or no zeros, or whatever vocab term you want to put. Roots, intercepts, or zeros. On number 2, it does have 2. Where? Every group can have a point. Okay, and I do see that number 3 has 1 root, but where is that 1? It is at -4. 2 and 3 can have a point. Okay, so far so good. Thankfully they graphed those for us. Now we need to start graphing ourselves. What's the issue with number 1? Yes. Yes, ma'am, and yes, Angel, but she went ahead and said the vocab term and everything. It's not in standard form. We need to add 12 to both sides and make it x squared minus 8x plus 12 equals 0. Now it's in standard form. Now we can graph it. If you put the equals 0 in your calculator, it's never going to work. You literally just type in x squared minus 8x plus 12. Okay, so I graphed it, and I did my zoom standard, and I think I know the answers. What do you think the answers are? Two and 4 at the point. Okay, so it looked like 2 and 6, and I agree on my calculator that it does look like it's crossing at positive 2 and at positive 6. It does look like that. How could I check that? Someone first here said trace. Trace is great for about the y-intercept, and that's about it. Trace is such a letdown. I don't know why they have a trace. Trace is dumb. If I go look at the table, an x-intercept means that my y value is 0. So I'm looking for 0. So yes, there's a y value of 0, so there is a root at 2. So I just need to scroll and check on 6. 6 also says 0. So you're correct, it is 2 and 6. I can prove it with my table. Okay, are there any questions on number 1? Okay, then, the only way they could really make this complicated today is to super not put the equation in standard form. So on number 2, we have to really rearrange that equation. And it stinks because if Gilberto rearranges incorrectly, that means he's graphed the incorrect quadratic function and he has the wrong answer. So everything goes downhill if we don't handle this one part correct. So I'm going to do it one step at a time for those scenarios. I'm going to add 2x to both sides. So I have 12 equals x squared plus 2x plus 16. But I'm still not done because that 12 is about, I got to move them. It's got to be 0 equals. So if I subtract 12 from both sides, I've got 0 equals x squared plus 2x plus 4. And this is what I need to graph. X squared plus 2x plus 4. What do you get as your answer once you've graphed that function? 5 gets the point. Once you've graphed it, you'll realize there are no roots, meaning it never crosses the x-axis. If you look at our graph, it never actually crosses the x-axis, so how would we find an x-intercept? We can't. There isn't one. Okay, number 3 seems great because, are there any questions on 2? Yes, and sorry, back to number 3. Number 3 seems great because it's already in standard form, which means there must be something more. There's always some trick up their sleeve, so something must be hard about it. It is. They're both in that second quadrant, that's true. What looks tricky about it once you've graphed it?
You can't really tell.
No, you really can't tell where that root is. I'm thinking, do you think it has 1 or 2 roots? I mean, it's kind of hard to tell. Is it just 1 right here?
No.
Or is it actually 2, like 1 right over here and 1 right over here? But then why don't we actually see it a little more below that axis? So we're not sure. So again, you can press second table and stare at things. The second table is going to let you down. So second table, if I go looking at the negative values. Oh, no, second table didn't let me down. It didn't know the answer, sadly enough. The answer is -4. The 1 root at -4. But there's so much better way. There's a much, much better way to figure this out. If you press second calculate, we're not looking for min or max anymore. We're trying to find zeros. So we're going to press the button that says 0. But just like before, you set a left bound, so point, pick a spot to the left of where you think. Come on, monster. Where are you? There you are. Left of what you think. Pick a point to the right of what you think. Guess. And it tells you the answer. -3.999, so you can see how they rounded that to -4. So it really does have a 0 at -4. So again, I did that kind of fast. I'll do it again. Second calculate, 0. I'm moving my monster around. I pick a spot to the left of where I think, a spot to the right of where I think, and then you got to make a guess. It doesn't have to be a good guess. And it literally tells you the answer. Oh, that time it actually says -4. It's a -4. Okay, so number 3 is -4. It has 1 0, and that 0 is at -4. What that means factoring wise is we probably have a double root, so it was like x plus 4 squared. If you're trying to think of how this relates to factoring. Okay, number 4 needs to be rearranged to standard form. Can someone tell me how to rearrange it and get the group of points?
-3x squared plus 2x plus 4.
Okay. Gilberto is correct in that we are supposed to add 11, but he knows I'm going to give the point to Jax because not only did Jax add the 11, but Jax also put that 2x back in the middle. Now, if Elizabeth graphs it on her calculator as -3x squared plus 4 plus 2x, your calculator's smart. It's still going to have it down as long as you move that 11 over. But Jax understands math teacher and me likes it in standard form, and he put it there. Okay, so let's graph it and let's figure out these answers. You don't know the answer. And I'll give you a point for that one, Paige. If someone else comes up with the other one, I'll give them a point.
No real.
But it has 2 of them. Jax, you get the other point. Okay, so we graphed it. Our graph looks like this. Does anyone have a graph that doesn't look like this? Okay, so I was going to look at my table, but before I even started to look at my table, I already knew it was going to let me down because I can tell that where this is crossing, it's in between those 2 dash marks, which means it's not crossing at a whole number, which means second table was never going to help me out. When you press second calculate, and you go to 0, it's a little more complicated than when we were doing max or min, because when we were doing max or min, there is only one max, there is only one min. But on the screen right now, I have 2 zeros. So when I set my bounds, I have to be careful, because I need my bounds to include just the 1 0. If I set my bounds too wide and include both zeros, I'm going to confuse the bejesus out of my calculator. I need to literally have between the 1 bound and then between this bound. So I've got to be more careful with my bounds. Okay, so where are you, monster? I set my bound to the left of this point. I am to the left, so press enter. I set my bound to the right of this point still. I am to the right, I press enter. I make a sneaky guess. And I get negative 1.63. Is that what you said on the page? Didn't you say negative? Did I graph it wrong? Negative 3. I did. I knew your number was right, so there was something wrong with my graph. So negative 3x squared plus 2x plus 4. Yeah, graph. There we go. Okay, so when I did second, calculate 0, little to the left, enter, little to the right. Oh, Miss Compton, press the right buttons. Enter, little to the right, enter, it tells me the answer. It is negative 0.86, or I'm going to write negative 0.87. So she was correct. I'm saying number 4 is negative 0.87. And my second 0, I kind of already thought it was 1.5. So you could be fancy and just change your table set and make it count by 0.5 to check it all out or whatever. So I think your table actually does know this one. Oh, I'm wrong. Anyway, if you change your table set to not count by ones, but to count by halves, you could check it out that way, but why bother? Why not second calculate 0? When you set it to the left, you've got to be careful. This point can't be involved. So when you pick to the left, make sure you're picking past that first 0. So it has to be here or further along. To the right, just go past your point, I guess. Yes, 1.535, so I'm going to say 1.54. So my zeros are at negative 0.87 and 1.54. Okay, are there any questions about this? Well, if you haven't shown me your checkpoint or your homework from last week, that's something you ought to work on and show me now. But you also have an additional thing today, 5 through 8. 5, 6, 7, and 8. 8 is on the very next top of the next page. Don't forget about it. There's a quiz to try. There's a quiz tomorrow. I think that's all the words I got.